Welcome back. Today we're going to be looking at a grid problem from Google Code Jam called Rotate. This problem is based on a game called Connect 4. In order to win the game Connect 4, you need to have 4 pieces in a vertical, horizontal, or diagonal line. This problem is a bit more generalized. It doesn't necessarily need to be 4 in a row, it's just going to be k in a row, where k is an integer. So what's going to happen is we're going to be given a board. We need to rotate that board and then apply gravity to it. And after we've applied gravity, we need to figure out if any players have won the game. So we have 4 different cases. It's possible that none of the players have won, the red player has won, the blue player has won, or both players have won. So we're simply going to be outputting that, either red, blue, neither, or both. And down below is a sample input and output, which we can use to test our solution before submitting it. Alright, so we can start by making our class, and the first line of input is going to be giving us an integer, which is the number of test cases. And we're going to be iterating over these test cases. And for each test case, they're going to start out by giving us a line containing n and k. So we can get these. So we have those 2 numbers now. Now we want to read in the grid, and the grid's going to be an n by n grid. So we can make a new array there. Okay, so we want to read in the grid. Make a comment here. Okay, so we're going to be reading in line by line, or row by row if you want to think of it that way. So int y equals 0, y is less than n. And for each line, I guess we need to read in the line, so we can store that as a string. See that next line. Okay. Now we want to iterate over each character in this line, which will represent a different column. So we're going to use a loop. Okay, now if the character that we're looking at is a period, that means it's blank. If it's an R, we're talking about the player red. And if it's a B, then it's blue. So we're going to, we can use a switch statement here, might be the cleanest way. So we're going to be switching the character string.char at x. I'll take the character we're currently looking at, and so the first case, if it's a period, then this is going to be a blank. So we need some way to represent what a blank is. So we can define some constants up here. Static final int blank. Let's just give us a value of 0. We need 2 other constants though. We want 1 for red. Let's give that value of 1, and 1 for blue. Give that value 2. Okay, so that's our first case. And our next case is if it's a capital R. So that means that it's the player red. So y x equals red. And final case is blue. Okay. So now we've read in our grid. Now the next thing we want to do is rotate this grid. But we can simplify this a bit. So instead of rotating it and then applying gravity, we can actually just apply gravity to the right, as opposed to rotating and then applying it downwards. So this just saves a step. It wouldn't be too hard to shift around your grid and rotate it, but there's no reason why we can't apply gravity to the right. So we're going to do that. So we're going to need to write a method to do this. So shift all R's and B's to the right. So we're going to have some kind of method which gravity to gravity to your right. And we're going to pass in this grid, and as we'll find out later, it'll be convenient to pass in the size of the grid. Okay, so this is going to give us a new grid where all the pieces have been moved to the right. Then after that, we want to find the winners, and then we're going to want to print the result. Okay, so let's start by filling in that blank, so the gravity to the right. So how are we going to do that? Okay, so this, we're going to have a static method here. It's going to be returning a new array called gravity to right. Okay, and we're going to be taking in a grid, and let's take the size of the grid. We could find that using length, but it's just easier. And we're going to be making a new grid. At the same dimension. Okay, so we're going to be going row by row. So int y equals 0, y is less than n, y plus plus. So we're going to be shifting them over from right to left. So what we're going to do is we're going to be iterating over the old array, starting at the right side. And every time we find something that's not a blank, we're going to be putting it in the new array, starting from the right. So we're going to want some kind of counter which starts at the right side and is incremented every time we add something, so that then things we're moving over don't go to the same spot. So I'm going to call that shifted x. And it's going to start at n minus 1, which is the last cell on the right. Okay. Now we're going to be iterating over the old array. X equals 0. Okay, so we're starting from the right, going to the left. If grid y x is not equal to blank, that means it's red or blue. Therefore, new grid y, and this is shifted x. But we want to subtract 1 after we do this so that next time it's in a new spot. This is going to be equal to either blue or red, depending on what was here before. Okay. And one nice thing about this is we don't need to initialize all the blank spots because we gave blank a value of 0. So when you create a new array, it's already 0. So this is going to work just fine, and we can return the new grid. Okay, so now we have the gravity. Now we're going to need a method to determine if a player has won. So we can make this generalized. Well, first we're going to give it its grid, the size of the grid, the number of pieces that we need in a row, and we're also going to give it the value of the piece. So that way we can pass in, we can use the same method for blue and for red. So now you need to think about the different ways that a player could win. We have the vertical case. We have a horizontal case. We have diagonal case, but there's 2 different diagonals. So we can go from bottom left to top right, or we can go another diagonal, top left to bottom right. So those are 2 diagonals. Now what we want to do is we're going to be making another method called count pieces in row. So count pieces in row. What we're going to give it is we're going to give it a grid. We're going to give it the piece that we're counting. We need to give it an x value. Just put x for now. A y value. So this is where we're starting to check. And then what we're going to be giving it is a dx and a dy value. So this represents, okay, which direction are we moving in? So in this case, we're going vertically. So if, so we're going to be, okay, so in this case, we're going vertically. So dx, well, if we go top to bottom, then dy would be 1. And if we're going bottom to top, it would be -1. So that just represents the direction we're going. For a diagonal, dx and dy will both be non-zero. And we're also going to just pass in n, which is the size of the grid. Now, we're going to be doing the same sort of thing for horizontal, diagonal, and the other diagonal. But there's n different verticals we need to check. So we're going to be putting this inside of a loop. So, okay, get the indentation fixed there. So for this one, we're going to be, the first value is x. So this represents which column we're checking. So we can just pass the value of I here since we'll be changing. So we're going to be checking a different column each time. The value of y, we can just start at the top. So value 0. So our dx is going to be 0. And we're going to be going downwards, so our dy is going to be 1. Okay, so if we find k pieces in a row, so if this is larger or equal to k, then we're going to be returning true. Because it doesn't matter how many times a player wins. As soon as we found a pattern which indicates that they have won, we can return true. So we're going to be doing the same sort of thing down here for horizontal. Count pieces in row, give it grid, piece. Okay, this time the x position is going to be 0. Let's start from left. And the y position is going to be changing each time we go through this loop. So this represents the row that we're on. So row I. And dx is going to be 1. We're moving 1 to the right. And dy is going to be 0. So we're staying on the same row. If that's larger or equal to k, then we return true. Same sort of logic for the diagonals. So this is going bottom left to top right. So what that means is we need to be careful here because there's not just n different spots we can check. So we're going to be breaking this up into sort of 2 parts. So either we start on the left side of the grid or the bottom of the grid. And for each of these, we need to go upwards and to the right and see if we can make some kind of line. The way that we're going to be coding in here, we're actually going to be counting, we're going to be overlapping along the corner. So we're going to be checking that twice, but just for simplicity of code, we can do that. As you'll find out, our solution isn't the most efficient, but it's sufficiently efficient for this problem. Okay, so for the first one, we're starting on the left, so we'll get a value of 0. The row is indicated by I, and we're going to be going to the right and upwards. If this is true, return true. And if we start along the bottom, then our position is I, and our vertical position is n-1, so it's just the bottom row, and we're going to be going the same direction, so 1, -1. Return true. I can't spell today. All right. So our other diagonal, so if count pieces, grid piece. Okay, so we're going to be starting, once again, we have to break this up into 2 parts. So the first case, we're going to be starting on the top row. So this is I and 0. And we're going to be heading to the bottom right. So dx is 1, dy is 1. We're going to return true. And the other case is if we start on the left side and head to the bottom right. So I, that's 0, I, and same direction. Okay. So if we checked all the possibilities and none of them are true, then we're going to be returning false. So the final method we're going to need is this count pieces in row. Where does that come from? Okay, so we gave it a grid. We're giving it a piece. We're giving it the x, the y, the dx, and the dy, as well as the n. So we have a lot of parameters, but that's okay. So we're going to need a few variables here. So we're going to keep track of the most amount of pieces that we counted in a row, start at 0, and we're going to have like the current counter. So every time this counter passes the max, we'll update the max, and every time we run into a piece that is not the piece we're looking for, we can reset the counter to 0. And everything that we need to be careful of is that we don't go outside the bounds of the board. So that's what this while loop is going to do. So we'll make sure that x is larger or equal to 0, and y is larger or equal to 0, and x is less than n, and y is less than n. So as soon as we go outside of the board, we know that we finished checking that column or row, whatever we're checking, and we can just break out of this loop and return the max, whatever that was. Okay. So there's two different cases here. If the piece that we're currently on matches the piece that we're looking for, we can update the counter. So counter plus plus, and max equals math.max. Okay. So I'll update the counter and the max value. Otherwise, we can just reset the counter to 0, because that means we finished our streak. And after we've done that, we need to move to the next position. So just x plus equals dx, y plus equals dy. Okay, so that method is done. So now we can return back to the main method. So we want to check to see if blue has 1 and red has 1. So I'll make some booleans here. So red has 1 equals, and we have a method for this. I call it isWinning. And this method is going to take the grid, n, k, and the piece we're checking. So we're checking for red in this case. So we want the same sort of thing for blue. Okay, so now we've checked to see if they have 1, and now we can print the result. So a variable called result. If blue is winning, if blue is 1 and red is 1, then both of the players have won. And the problem specified that we need to output this as both. Otherwise, if blue has 1, just blue is 1, because we won't reach this case if red is 1 as well, then result equals blue. Else if red has 1, result equals red. Otherwise, neither of them won. Neither. Okay, now we need to print the result, format it as they have specified. So they want us to put case number sign, and then the case number, starting at 1, which is our loop value, and then whatever string that we just built, we'll put in there. And of course we want to finish the line. So that's our case number, this is our string, which is called result. There we go, we should be good. So now we're going to run this on the terminal, make sure everything compiles right, and then test it against the sample input. Okay, so we can start by compiling it. Java rotate.java. Okay, we have an error, so we can look back at our code. I just made a simple mistake here. I reused the same variable name, I declared it again. Also, there's no reason that we need to split a line that only has one thing on it. So I can just refactor it to that. It's a lot better anyway. Okay, so now it compiles. Now we can run this against the sample input, which I put in a file called test.in. Did not do that right. Sorry, I didn't pick the file name. Okay, so that's what our program outputs. We can compare that to what it should output, and they match, so that's good. Next, we can go on to Google Code Jam, grab the input files that we actually need to generate, and generate our answers. I've already downloaded those, so we can run this now. Java rotate, feed it the file, so it's called a-small practice.m. This is the small one, and let's output this into a1.out. And do the same thing for the other one, for the large data set, and put in a2.out. Okay, so now we've generated our answers. Alright, so let's select our files, a1.out and a2.out. And we can submit both of these. First one's correct, second one's correct, awesome. So thanks for joining us today. I had a fun time solving this problem. And if you have any suggestions for problems that you'd like to see solved, not necessarily Code Jam, there's lots of other cool websites that have programming competition problems. But yeah, if you have any suggestions, just comment below, and I'll see you next time. Bye.